Hello and welcome to the Cloud Chronicles continuing series on Azure networking. Today we're going to be discussing, I think, one of the more interesting topics in Azure networking, which is load balancing. We're going to talk about all the different options. So if you're taking AZ305 or AZ700, pay attention because you'll probably get a lot of questions on this. I'm
Yes.
Joey Dantoni and I'm here with my colleague, John Morehouse. I'll let him introduce himself.
Hi, I'm John Morehouse. I'm a principal consultant with Dantoni and Associates Consulting. Uh, I like Azure stuff. I like the, and actually, I'm find that I really like the Azure networking piece too.
And I'm Joey Dantoni. I'm a Microsoft Data Platform MVP, and I'm Principal Architect now at Three Cloud Solutions. I was at Design Mind. We just had a little bit of a merger this week, so I have officially a new job, but it's the same job. Uh, we're going to talk today about Azure load balancing. This is kind of an interesting story because John, this is how I really got into Azure networking.
Oh,
Because
really?
the first time I did anything really crazy was in like 2013. I did a talk at Pass Summit on a hybrid always-on availability group that was running on my laptop over a point-to-site VPN into Azure. And the only way you could create a listener, and it's not the only way anymore, but it's still my preferred way in Azure, an availability group listener, is to use a load balancer.
Balancer.
At the time in 2013, load balancers were only available on public IP addresses, which made for less than good security for your availability group. Things have evolved a long way, though, and we're going to talk about a wide array of topics here. Uh, you just took 305. Why does load balancing matter?
Well, so and I did take 305, and thankfully I passed 305, which is about a lot of networking in Azure. And so you have to understand when you put together a solution in Azure how to effectively route traffic to your Azure resources appropriately. And there's actually a doc online that shows a really nice, like, and as Joey mentioned, we're going to go through pretty much all the concepts of the load balancing world in Azure. But there's actually a comparison of like, if you've got this, do this load balancer. If you got this, do the other one. But you have to understand what all those solutions do and how they work.
For sure, it's they're different layers. We're actually going to talk about the OSI model, something that scared me for a long time, but I
Still
learned to
scares me.
love it. And if you're new and have never worked in a non-cloud environment, we used to actually have hardware, uh, believe it or not. Uh, but yeah, so some of the services we're going to talk about today include the normal kind of Azure load balancers that are built in. We're going to talk about Azure Application Gateway and Azure Front Door, which are layer 7 load balancers as opposed to the layer 4 load balancers that are
Protocols.
protocols. And we'll also talk about Azure Traffic Manager, which is a DNS routing solution, which I really like for a number of different solutions. I've helped customers migrate from on-prem to Azure using Traffic Manager, specifically for websites. But what's interesting is, and we don't have access to this, but for those of our audience, because John and I are both data platform MVPs, I think both Traffic Manager and App Gateway are used to front SQL database.
Well, that makes sense.
Because Microsoft has some magic to like make SQL Server talk HTTP that we don't get on prem. So that's like how they're able to use this for networking transporting layers. Uh, so just to dive in a little bit, you talked a little bit about load balancing, but what are some examples like where you would see load balancing being used typically? It's more databases are kind of uncommon, right? It's more for stateless apps.
Typically, the only place I see a load balancer is just like what you mentioned, where you're going to stand up a load balancer for a listener for an availability group, between two replicas and for HA or DR.
Mm-hmm.
I actually just stood up a traffic manager for load balancing for a client to do some DR in case their
Mm-hmm.
primary region died. So they have a secondary copy of their application running in a different region, and we use Traffic Manager to facilitate the failover piece of that in case the primary region died. So that's one thing to do, and that Traffic Manager, there's different priorities. Like you can specify different things with that particular solution, but even like load balancing performance wise, right?
Mm-hmm.
So if you have stateless apps, and you've got 10 of them, you can use a load balancer to ensure that all 10 get equal amounts of traffic and you're not overloading one versus the other.
Yeah, really anything that kind of auto scales, like
Yeah.
in Kubernetes, you're going to end up using load balancers. That in Kubernetes, it's weird because you have load balancers that are internal to the cluster that you'll also use, but you'll front end those with like a cloud type load balancer, and that can be either an app gateway or a load balancer. But also like VM scale sets or Azure app services. So like if you have an app service that auto scales, like there's load balancing in front of that. So
Yep.
really, there's a whole lot of different places you use these in the cloud. One of the things that's really interesting is this was a service that we always had on prem, but like it was one of those things that only enterprises had, because to get an F5, which was the load balancer I remember back when I worked at Comcast, it was
Make it
a
rain.
lot of money. Like
Yeah,
they
it
were
was.
really expensive. Like I think Comcast was the only place I ever worked that had them, and I worked at some pretty big companies. Uh, but yeah, those things were expensive.
I had a couple clients way back in the wind that had a couple F5s.
Yeah, and by the way, once again, if you're not old like us, F5 refresh, they named their load balancers that because people would hit F5 if you couldn't get to the website, and if you could load balance, then voila.
Yep.
All right, let's talk about the OSI model, and this is something. It's an old school thing that I don't think I ever knew. I have a slide, and I'll share it. Hang on.
I knew about it. Like
Yeah, yeah, yeah.
I knew it was there. I didn't understand the inner workings of it.
Yeah, I don't think I really learned this until I actually had to teach Azure because I knew it was a thing. So, layer one is the physical layer, and that's going to deal with cables and switches. In cloud world, this is something we never, ever, ever see.
See. Yep.
Like, uh, not really something we ever deal with. The only place you might deal with it's in your house for your internet connection. Layer two, the data link layer. This is going to handle MAC addresses and direct point-to-point communications. Once again, not something we manage in the cloud. Layer three, this is the first place we start to deal with stuff in the cloud. We are responsible for our own IP addressing and Azure Virtual Networking and routing. We have control over routes and how data moves through our network. Layer four, and we'll talk more about 4 and 7 on the next slide. I'm going to hand off to John and let him kind of speak to that. This is where we're ensuring reliable delivery via protocols like TCP and UDP. Layer 5, we have the session layer, which is going to maintain connections between apps. So if you have, for example, a client application and a database server, that's where that's going to be maintained. And then finally, or not finally, the presentation layer, so transport data formats for interoperability, things like encryption and compression, so TLS compression, those sorts of things. And then finally, the application layer. So this is where the network's going to interface directly with user applications. This is typically going to be over HTTP, HTTPS, hopefully not FTP. That protocol's insecure and older than God. SFTP, SCP, any of those protocols where you would talk, even Telnet. I still use Telnet a lot to test ports because if you're
It
on a
works.
Mac, test-net connection does not work.
It works. Whatever you need to use to verify connectivity.
Yeah, John, talk a little bit more about layer 4 and layer 7 here.
Sure. Layer 4 and layer 7. And what I will tell you, at least from my experience, all the solutions that Azure has, and we're going to go through them, they deal primarily with layer 4 and layer 7. As Joey mentioned, we won't play around with layer 1 because we won't get to the cables. So layer 4 is the protocol layer. So it's going to handle traffic based off of TCP/IP, UDP traffic itself. It's not going to be able to listen on things like HTTP or HTTPS. So things like an actual load balancer where you want to load balance performance across multiple services, web apps or what have you. It's going to listen on the TCP or UDP traffic itself. Whereas layer 7 is the application layer. So as Joey mentioned, it's going to listen at the higher level with the HTTP, HTTPS. Application gateway and front door are layer 7s. You do get more advanced. Layer 4 is strictly just those protocols. Layer 7, you can actually do routing based off of not just performance, but you can also do routing based off the URL string that you're trying to get to, right? So if your URL string has photos in it, it might route to a different destination than not having photos. So layer 7 gives you a lot more advanced routing capabilities if you want it. But depends on where you need to route things and how you want to route them is kind of how you determine where that is.
I can tell you just took the exam because the photos example is like
Is
straight out of docs,
Yeah,
as I
it is because I may
remember
have
correctly.
studied it over and over and over and over again.
Yeah, I thought I remembered that.
Yeah, nope, it's there because I wanted to make sure I tried to pass that exam, so I studied it over and over again. Because
Yeah,
OSI,
yeah, yeah. The other thing App Gateway does, and I think Front Door does as well, is uh, you can do like some URL rewriting. So you
yeah,
can even
yep,
do beyond just like routing traffic. You can do some redirection. And
yeah.
we have a
You get a lot more capabilities with layer 7.
yeah. You have a client that does some really crazy stuff with an App Gateway in terms of like the way they route traffic, and they have URL rewrite and all sorts of things like that. Uh, So let's talk about load balancers. The first thing about load balancers is they're really cheap. The basic load balancers I think are free. They don't inherently do a whole lot, other than like John said, route TCP traffic. Let's. I'm gonna go ahead and you. So tell me about how you'd set up a load balancer for an AG, and I'm gonna go ahead and set up one in my Azure portal here on the screen.
I have never set up a load balancer for an AG.
Oh, you haven't.
No, I've always done the um,
Interesting.
DNS versus VNN route.
Let me make sure. So the main reason I mentioned this earlier, the main reason why I prefer those for AGs as opposed to what John's talking about with the distributed network name is you control the port. So like
That's true.
yeah, you have control over the port. So I have a couple of things that are really terrible here. This is my domain controller. You'll note it has a public IP address. Don't do that at home,
Yeah, don't
kids.
do that.
Uh, But let's go ahead. I'm going to go ahead and create a load balancer in front of this because it doesn't matter. So here, I'll go ahead and add a load balancer. Create. And I went down the wrong path. So let me go to resource group infrastructure.
You might want to zoom in too.
Oh, sure.
There you go. Now, load balancers themselves are regional.
Regional and can cross zones, but yeah, like John mentioned, they are limited to a single region, single VNet.
The other thing why Joey does this is there is a concept of a global load balancer, which can kind of get confusing
Correct.
because
Yeah,
you're basically load balancing across load balancers.
but those have to be public, as you can see
Yes.
here. So
Yes.
like if I choose regional, if I choose internal, it can only be regional.
Yes.
Yeah, in this where this global load balancer concept gets confusing is when you start talking about front end and app,
Yep.
or front door and app gateway, because they do similar things. But remember, this is only layer 4.
Yeah, and I found the documentation relatively confusing in terms of global load balancer. You're just load balancing across multiple load balancers.
So here we need to give this an IP. So we're going to add it.
You give it a public IP, and then
This is a private IP. This is assigning.
okay.
Just
Well, you're
assigning.
doing well. Okay, you give it an IP, a front end IP that you communicate with, and then you have a back end pool.
Yeah, exactly.
Then your back end pool are your replicas in the AG.
I'm bad at IP address scoping on the fly.
You don't have your Excel spreadsheet open.
Yeah. Okay. So you can make these zone redundant or not. I'm gonna say no zone because I don't have this in a zone and it's gonna front end one VM. And here,
Here you would say SQL or
yeah,
something.
here you'd say SQL. I don't have a VM here. This is weird. Let me just.
Are you in the wrong
It might be
region
in the wrong VNet.
or that?
Oh, it's in SQL DB VNet. Okay, we're gonna skip the rest of that demo. But basically, what's gonna happen there is you're gonna configure. You configure your backend pool, and then you configure health probes. So since I was working on a domain controller, I don't really have I don't know how you'd health probe a DC, but like for example on SQL, you put your health probe on 1433. It checks for a response. It makes sure it can access that, and then there's also a probe port. And basically what happens is if it no longer gets a response, it will fail over. And there's a little power for SQL AGs, there's a little PowerShell trick you do uh, where you can effectively connect the cluster to that load balancer, and that will handle the flip. So it's cluster aware, and you define a probe port in your cluster as part of your cluster resource there. And typically that's like a very high TCP port, like 59,999. Is
Something
my
high.
usual go-to there. Anything else about like I would say the only con about them is they're a little messy. They're a little messy to set up. They don't do a whole lot. But if you just need basic kind of round robin load balancing for stateless apps, or if you're using a SQL AG and you want to be able to connect to it on 1433, the load balancer is your tool of choice.
I would agree. If you're looking for anything like that's true DR where you need to move traffic outside of a particular region, load balancer is not going to be your solution there.
Well, it's complicated too because like with
Sure.
SQL and VMs, if you're building an AG across regions, you would end up having a load balancer in each region,
Sure.
and you would define that as like a multi-subnet AG. That's the one thing I think we
Sure.
probably.
I'm thinking web apps.
Yeah, for sure with web apps. Yeah, that's definitely not the case. But just if you're doing the SQL side of that, that's the way to
Yeah.
go.
Yeah. If you're doing that load balancer route.
Also, our next solution, another like kind of single region thing, is application gateway. And since you're the new architect,
Oh, great.
let's talk about app gateway. We know it's a layer 7. I built one of these ahead of this, and I'm gonna pull it up as John's gonna kind of describe it, and we'll walk through some of the features.
So, and I like app gateways. One of the reasons I like app gateways is it does have a web application firewall that you can select when you create the app gateway. Did you put the WAF in there?
I don't remember if I did.
Looks like your standard V2, so you did not.
Yeah.
So when you create the app gateway, you can bake in a web application firewall that will automatically and define a policy, just like what Joey's doing here, and that will automatically check all your traffic for malicious attacks like SQL injection or cross-site scripting, as it mentions there in the description. So it's another layer of security when you start to deploy things like web applications that sit behind the application gateway to ensure that your traffic is nice and secure, because you don't want to do like what Joey did and put a public IP on a domain controller. So application gateways, layer 7, you get the WAF, you get that advanced URL-based routing, you can actually do path-based, that's the photos thing that I mentioned. They're great for web applications, microservices. You also get SSL termination through the traffic, which is a great thing to have as well.
Yeah, so the benefit of that SSL term is instead of actually going all the way to your web server encrypted, the app gateway handles the SSL termination on it, which basically reduces the load of the CPU on your web server.
Yeah, it can. I haven't looked at pricing recently. App gateways can get up there in cost.
I want to say
remember
they're about
correctly.
$1,000 a month by
Yeah,
default. Like it's not a cheap solution. I think like there's a WAF only
yeah,
one that's a lot cheaper.
yeah. We just stood up a secondary gateway for that client that I mentioned that I did the front or not traffic manager. Sorry. And we were able to find a tier, a SKU that was cheap enough for them to work with a WAF.
One thing to mention though, with an app gateway, you can cover multiple sites. So these listeners
Yes.
can be mapped to a site. Like I know at one of our former clients, we actually tested the limit, or one of my former clients, we tested the limit of this. Like you can put 100 sites behind these, so you can just kind of keep adding and using it. They will auto scale, so if the traffic's really busy, it will scale out and your costs will go up. But if you're really just using this for routing and data protection, you can get your money's worth. Like the upfront cost is pretty high, but the rest of the cost isn't that bad.
And it's regional, yeah?
Yeah. App gateways are tied to one region. We're going to talk about front door next, which is effectively like the same thing, but across regions.
And or global.
And or global. Here you can do some of that URL rewrite that we talked about. Uh, the other thing that we don't super have an app gateway that Front Door gives us is CDN integration. So there's no CDN stuff built in here. But the basic idea is it's a layer 7 load balancer. So things like APIs, e-commerce platforms, this is what going to be what you want to use. Where it's limited is like John mentioned, it's a single region. So if you're only doing things in a single region, that's pretty much going to be where you want to stop.
And CDN is content delivery network.
Thank you very
Basically, it's
much.
caching for
Yeah, yeah,
things.
yeah. So let's talk about Front Door. Front Door is a service that I feel like is constantly under DDoS attack. Uh,
Yes.
yeah, like this is Microsoft's service that they use to like host. So when the portal's down, it's because there's Front Door is probably getting DDoSed, and Microsoft's like teraflops of network can't deal with that, uh, which means it's a really bad DDoS attack. Front Door is a global load balancing and performance optimization service. So basically everything we said about App Gateway, Front Door can do, plus a little bit more. Uh, it's multi-region, so it can be global. It's got web application firewalls, uh, and it has global load balancing and performance optimization. So that CDN integration and caching means you can have integrate it with a content delivery network and have a local cache in each of your regions. So that, let's say you have an app that's running in Central US and UK South, so London. Uh, you're going to have a cache that's sitting in the Chicago area, and you're going to have a cache that's sitting in London. It's not going to be limited to a single region like App Gateway. Uh, I think I've seen some scenarios where, because people want like URL rewrite and such, they'll combine App Gateway with Front Door for really high scale applications. Uh, but for the most part, I see like one or the other as chosen. And it's usually the delineating line. And this is probably what the exam table said in that docs page, is multi-region, right?
Yes.
Yeah, yeah. Multi-region,
Yeah.
and do you have budget?
Yes. That too.
Yeah.
Yeah. And I don't have any clients running Front Door, so I have not seen it.
We had like one client when I was still at DCAC that we
If we did, I don't remember who it was.
yeah,
But
I don't remember who it was, but I remember, and then of course, Microsoft, of course,
yeah.
has it. But yeah, that's the basic idea. Front Door and App Gateway are really similar services. They're just App Gateway is limited to a single region. Front Door is not.
Yep. And that is the delineating factor.
Yeah. All right, let's talk about my other favorite service in Azure networking.
I like this service too.
I like this service too. It's called Traffic Manager,
And it's cheap.
and I think I might have mentioned this in the intro. I've had customers use this for migrations. There's a whole lot of reasons to use this service. And Traffic Manager isn't like inherently a load balancer. It's a DNS routing service that creates kind of a front end for your DNS. And I know DCAC uses it. And
Yep.
so DCAC.com actually maps to DCAC.trafficmanager.something
.net.
Microsoft.com, right?
Yep. Yeah, it's trafficmanager.net, I think.
.net. And so when you hit that, based on, and I think the way DCAC is configured, it's based on your geolocation.
Hang on, I'll tell you.
John shared a map. I'm going to show.
It's actually based off of performance.
Oh, it is based off performance.
Yep.
Okay. Yeah, right. Because geolocation's routing. So John's going to talk about the different options you have with Traffic Manager. So effectively, based on the last, I think the performance method's like the last 5 or 10 hits, or something to that effect. So based on your latency to the nearest endpoint, it's going to route you to the best endpoint. And DCAC is in Central US and Western Europe, which is north and east of, or Northern Europe. I always get this backwards because Ireland and Chicago basically is where the DCAC website lives, as I recall. So you can see the various latency, like we see the scale of the white records there, very low latency, and the red ones are very poor latency. And you can vaguely see where that's kind of tied to geographic distance from each of those locations.
I think that map is really cool to have when you have Traffic Manager enabled to see where your traffic's actually coming from.
Mm-hmm.
I think that's really slick.
Yeah, it
I
can
think that's a neat feature.
it can kind of help you make decisions around like where you're going to put, like if you wanted to put an additional web server, if you had a
Yep.
lot of customers there, like as you can see, DCAC has some decent traffic from Asia, so like maybe Singapore
Yep.
or maybe the Japan region might be a good place to put some traffic. What are some of the other options there for besides just performance and geography?
There's, Traffic Manager actually offers like 6 different options for routing traffic. You've obviously got the performance, just like what Joey mentioned here, that DCAC is configured for. You can do a priority. So, like the client that I just stood up a Traffic Manager for, their primary region is set as the priority 1, and then their secondary region is set as priority 2. So, Traffic Manager will basically continuously ping their app in their primary region, and if they don't get a response like 6 times, Traffic Manager will then start to redirect traffic to their secondary region, where their secondary app is just sitting there waiting to accept traffic. In the future, they could change that from priority to performance if they really wanted to load balance across the 2 regions. But right now, so they're using priority. So you can designate a priority, and it'll always go to that priority target unless something happens.
Yeah, the other part of that, just to mention, there's a geographic routing where you can configure basically traffic from each country.
Yep.
So, like, if you think of a crazy international e-commerce site like uh, IKEA, depending on where you are, lands you on a different homepage. A lot of sites will do this based on your IP address. So you could have like a different path to a different website that way. Uh, you could also do that in Front Door. It's actually a lot harder to do that in Front Door than it would be in Traffic Manager. So like that would be kind of a good example of where you would use that.
And that's another way to route traffic. And I think the geographic routing, I think, is really cool, especially because Traffic Manager is cheap. That's a
Yeah.
great way to route traffic to your closest resource. You've got performance, geographical priority. You've also got weighted. You can weight the traffic across multiple endpoints, so you could weight them all evenly, or gauge your weights, and it will handle traffic effectively that way. You also have multi-value, which are basically IP4 or IP6 addresses as endpoints. So as long as the endpoint is healthy, that's where it's going to go. And then you also got subnet. So you can actually, based off the subnet of the end user's IP address, you can route that traffic. So if Joey's subnet was one value, he would go one direction, and I'd go a different direction because my subnet's different than
I'm
his.
trying to think of why you would want to do that.
I'm not sure.
Yeah. Like in a private network, I can absolutely understand why you would want to do that. In a public network,
I think it'd be difficult. Private, I could see, because if you
yeah,
wanted to
yeah,
route, I
yeah,
don't know, your IT subnet somewhere else. I don't know.
yeah.
Right.
That's a really good open question. Maybe I'll write a blog post about that. All
I,
right,
I,
let's just kind of recap the services. So, load balancers, those are mostly going to be used mostly internally, maybe for some lightweight load balancing for a public website that's not super busy, where you just want to do kind of round robin routing and you don't really care about anything special. App Gateway is going to be kind of a more powerful version of that web load balancer. Uh, it's gonna be able to do things like SSL termination, health checks, and
WAF,
rerouting rules. What were you saying?
WAF.
WAF, Web Application Firewall. Front Door is going to do a lot of the same things App Gateway does, just multi-region. And then Traffic Manager is a DNS redirection service. So it's very possible you would use Traffic Manager in conjunction with App Gateways in multiple
Yep.
regions, especially if you only had a couple of regions, or App Gateway in conjunction with Front Door, or even Traffic Manager in conjunction with load balanced web apps. These are all things you could use in combination. It's just going to depend on the needs of your particular network. So all kind of things to keep in mind. John, what do you think are some key takeaways from this?
I think understanding where each solution can play in your organization is going to be a big part. Obviously, if you are usually confined to the United States, you might not need Front Door. And as Joey mentioned, you can use Traffic Manager and App Gateway to facilitate routing effectively at a decent price point. I mean, you could go crazy. You can swipe right and spend all the money if you wanted to. But understanding what layers you want to do routing at, layer 4 or layer 7, as I said, those are the two main components that we will route traffic on through Azure. Then you can pick what solution works best for you.
Yeah, in my experience with doing a lot of these projects, the use case becomes glaringly obvious when the customer starts to give you the requirements of
Yeah.
what they need the app to do, right? Like, we need
Yeah.
this
I mean,
public website. We need,
cross region. I think that's
yeah,
the big.
yeah,
If you have to cross, regions, then you're limited to like two.
yeah.
I mean,
Yeah, and then
effectively.
traffic manager is almost something you should like always use in general anyway.
Yeah.
Uh, just because one of the things, and we didn't really talk about this, and we're almost out of time, is multi-cloud solutions would be an example of where you'd use traffic manager, but it's always a little bit of a headache. AWS has a similar service called Route 53 that kind of does a little bit of the same thing. But I'm always like, if you're multi-cloud and you want to have a web presence in both clouds, just in case, which is to me that's the best use case for multi-cloud is to host a website. But like, where do we put the DNS?
Yeah.
Use Cloudflare, maybe.
Yeah.
Yeah, which is probably running in one of the clouds anyway.
Yeah.
Anyway, thank you for joining us. I think this was a really cool talk on all the various load
I love
balancing
this talk.
solutions. Like and subscribe. This network series is part of a series we've been doing. We're going to wrap this up in a couple episodes and probably do some stuff on cost management and then a little bit more on Azure data because after all, we are data platform MVPs.
MVPs.
But thank you for joining us and see you soon.
Thanks. See you around.